I am unable to directly access Proposal 1-64 of the 1994 Report on Proposals. Locating this document might require several strategies. Firstly, explore online databases. Many organizations and libraries now digitize and archive older documents. Search for the National Fire Protection Association, as the Report on Proposals is likely an NFPA document. Use specific keywords like NFPA 1994, Report on Proposals, and Proposal 1-64. Secondly, contact libraries, particularly those with extensive collections of technical standards and codes. University libraries with engineering or fire science programs may also hold relevant archives. Check the library's online catalog or contact their reference desk for assistance. Thirdly, reach out to the NFPA directly. They may have archives of past reports on proposals, although access might require membership or a fee. Consult the NFPA website for contact information and details on accessing their resources. Fourthly, consider professional research services. Some companies specialize in locating hard-to-find documents. These services may charge a fee but can save time and effort. Fifthly, explore government archives. Depending on the proposal's content, relevant government agencies in Massachusetts might have copies. Check state archives or agencies related to fire safety or building codes. When conducting your search, be aware of potential changes in document availability and access policies over time. Resources that were once readily accessible may now be restricted or require special permission. Be persistent and use multiple search strategies to increase your chances of finding the information you need. You might also consider alternative, related documents. While you may not find the exact Proposal 1-64, other proposals from the same report or subsequent revisions of relevant codes might offer similar information or insights. Also keep in mind copyright restrictions that might impact access. Many standards and codes are copyrighted, which could limit how you can access, copy, or distribute them. Ensure you comply with all applicable copyright laws when using any documents you find. In summary, locating older standards and proposals can be challenging but not impossible. Employ a combination of online searches, library research, contacting relevant organizations, and considering professional research services to improve your chances of success. Remember to be patient and persistent in your search. Also, consider that the information contained within Proposal 1.64 might now be superseded by current codes or regulations. Therefore, consulting the most recent versions of relevant standards is crucial for ensuring compliance and safety. Consider the specific subject matter that Proposal 1.64 addresses. Is it related to electrical systems, fire protection, building construction, or another area? This focus can help narrow your search and identify the most relevant resources. If you are focusing on electrical systems, the National Electrical Code, also known as NFPA 70, might contain information. If focusing on fire protection, the NFPA 13 covering the installation of sprinkler systems could be relevant. If it relates to building construction, various parts of the International Building Code might provide relevant data. When researching electrical installations, understanding concepts like voltage drop is also vital. Voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor and the current flowing through it. Excessive voltage drop can cause lights to dim, motors to overheat, and equipment to malfunction. The National Electrical Code provides guidelines for minimizing voltage drop in branch circuits and feeders. The recommended maximum voltage drop for branch circuits is 3%, and the recommended maximum voltage drop for feeders is 5%. These limits help ensure that equipment operates efficiently and safely. For example, consider a 120-volt circuit supplying a load that draws 20 amps. If the total voltage drop in the circuit is 6 volts, the voltage at the load will be only 114 volts, which could cause the equipment to malfunction. To calculate voltage drop, you need to know the length of the conductor, the current flowing through it, and the conductor's resistance per unit length. The formula for voltage drop is volts drop equals 2 times length times current times resistance per 1000 feet divided by 1000. The resistance per 1,000 feet of different conductor sizes and materials can be found in Chapter 9, Table 8 of the National Electrical Code. For example, the resistance of 12 American wire gauge copper conductor is 1.98 ohms per 1,000 feet. If the length of the conductor is 50 feet, the current is 20 amps, and the conductor is 12 American wire gauge copper, the voltage drop would be 2 times 50 times 20 times 1.98 divided by 1000, which equals 3.96 volts. This voltage drop is within the recommended limit of 3% for branch circuits. Proper grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip a circuit breaker or fuse and clear the fault. Grounding also helps to reduce the risk of electric shock by keeping non-current carrying metal parts at or near ground potential. The National Electrical Code requires that all electrical systems be properly grounded. There are two main types of grounding systems: equipment grounding and system grounding. Equipment grounding connects non-current carrying metal parts of electrical equipment to the grounding electrode system. This includes things like metal enclosures, conduit, and motor frames. System grounding connects the neutral point of the electrical system to the grounding electrode system. This helps to stabilize the voltage and provide a path for fault current to flow back to the source. The grounding electrode system typically consists of a ground rod, a ground ring, or a metal water pipe. The National Electrical Code specifies the requirements for grounding electrode systems. When working with electrical systems, it is crucial to follow all safety precautions. Always to energize circuits before working on them. Use properly insulated tools and equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not qualified to work on electrical systems, hire a licensed electrician. Electrical safety is not something to be taken lightly. Improper installation or maintenance can lead to electric shock, fire, and even death. Always follow the National Electrical Code and other applicable standards when working with electrical systems. Moreover, understanding overcurrent protection is crucial. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. When an overcurrent occurs, the device opens the circuit, stopping the flow of current and preventing damage to equipment and wiring. Circuit breakers are resettable devices that can be tripped manually or automatically by an overcurrent. Fuses are one-time devices that melt when an overcurrent occurs and must be replaced. The National Electrical Code specifies the requirements for overcurrent protection devices. The size of the overcurrent protection device must be matched to the ampacity of the conductor it protects. The ampacity of a conductor is the maximum current it can carry without overheating. The National Electrical Code provides tables of conductor ampacities based on conductor size, insulation type, and installation method. For example, a 12 American wire gauge copper conductor with THHN insulation has an ampacity of 30 amps. Therefore, it must be protected by a 20 amp circuit breaker or fuse. Overcurrent protection devices must also have an interrupting rating sufficient to interrupt the maximum fault current that could occur at that point in the system. The interrupting rating is the maximum current that the device can safely interrupt without failing. The interrupting rating must be marked on the device. Selecting the correct type and size of overcurrent protection device is essential for electrical safety. An undersized device will trip unnecessarily, while an oversized device will not provide adequate protection. If you are unsure of what type or size of overcurrent protection device to use, consult the National Electrical Code or a qualified electrician. Furthermore, understanding wiring methods is also a vital aspect of electrical installations. Wiring methods refer to the different ways that electrical conductors can be installed. The National Electrical Code recognizes various wiring methods, including rigid metal conduit, electrical metallic tubing, flexible metal conduit, non-metallic conduit, cable trays, and cable. Each wiring method has its own advantages and disadvantages. Rigid metal conduit is the most durable wiring method and provides excellent protection for conductors. However, it is also the most expensive and difficult to install. Electrical metallic tubing is a lightweight and less expensive alternative to rigid metal conduit. However, it is not as durable and does not provide as much protection for conductors. Flexible metal conduit is used for short runs and in locations where flexibility is needed. Non-metallic conduit is a lightweight and inexpensive wiring method that is resistant to corrosion. Cable trays are used to support large numbers of cables in industrial and commercial applications. Cable is a wiring method that consists of two or more insulated conductors enclosed in a jacket. The National Electrical Code specifies the requirements for each wiring method. The wiring method you choose will depend on the application, the environment, and the budget. In addition to the wiring method, you also need to select the correct type and size of conductor. Conductors are made of copper or aluminum. Copper is a better conductor than aluminum, but it is also more expensive. The size of the conductor is determined by its ampacity. The National Electrical Code provides tables of conductor ampacities based on conductor size, insulation type, and installation method. When selecting conductors, it is also essential to consider the voltage drop. The voltage drop is the decrease in voltage along a conductor due to the impedance of the conductor and the current flowing through it. Excessive voltage drop can cause lights to dim, motors to overheat, and equipment to malfunction. The National Electrical Code recommends that the voltage drop in branch circuits not exceed 3% and that the voltage drop in feeders not exceed 5%. Moreover, understanding the different types of electrical equipment is also essential for electrical installations. Electrical equipment includes things like panel boards, switchboards, transformers, motors, and lighting fixtures. Panel boards are used to distribute power to branch circuits. Switchboards are used to control and protect large electrical systems. Transformers are used to step up or step down voltage. Motors are used to convert electrical energy into mechanical energy. Lighting fixtures are used to provide illumination. The National Electrical Code specifies the requirements for each type of electrical equipment. When selecting electrical equipment, it is essential to consider the voltage, current, and power requirements of the load. You also need to consider the environment in which the equipment will be installed. For example, equipment installed in a wet location must be rated for wet locations. Furthermore, it is important to understand the requirements for electrical inspections. Electrical inspections are conducted to ensure that electrical installations comply with the National Electrical Code and other applicable standards. Electrical inspections are typically required for new installations, renovations, and repairs. The electrical inspector will check the wiring, grounding, overcurrent protection, and other aspects of the electrical system. If the electrical installation does not comply with the code, the inspector will issue a violation notice. The violation must be corrected before the electrical installation can be approved. Electrical inspections are an essential part of ensuring electrical safety. They help to identify and correct potential hazards before they can cause harm. If you are planning to have electrical work done, be sure to obtain the necessary permits and schedule an electrical inspection. Moreover, understanding the requirements for special occupancies is also crucial for electrical installations. Special occupancies are locations that have unique electrical hazards. Examples of special occupancies include healthcare facilities, hazardous locations, and places of assembly. Healthcare facilities have special requirements for electrical systems to ensure the safety of patients and staff. Hazardous locations are locations where flammable gases, vapors, or dust may be present. Places of assembly are locations where large numbers of people gather, such as theaters, churches, and schools. The National Electrical Code has specific requirements for electrical installations in special occupancies. These requirements are designed to address the unique electrical hazards present in these locations. When planning an electrical installation in a special occupancy, it is essential to be aware of the specific requirements for that occupancy. Furthermore, understanding the requirements for emergency systems is also crucial for electrical safety. Emergency systems are electrical systems that are designed to provide power during a power outage. Emergency systems are typically required in healthcare facilities, high-rise buildings, and other critical facilities. Emergency systems can include generators, uninterruptible power supplies, and battery systems. The National Electrical Code has specific requirements for emergency systems. These requirements are designed to ensure that emergency systems are reliable and can provide power when needed. When planning an emergency system, it is essential to consider the critical loads that need to be powered during a power outage. You also need to consider the duration of the power outage and the capacity of the emergency system. Moreover, understanding the requirements for renewable energy systems is becoming increasingly important. Renewable energy systems are electrical systems that generate power from renewable sources such as solar, wind, and hydro. Renewable energy systems are becoming more common as people seek to reduce their reliance on fossil fuels. The National Electrical Code has specific requirements for renewable energy systems. These requirements are designed to ensure that renewable energy systems are safe and reliable. When planning a renewable energy system, it is essential to consider the location, the climate, and the energy needs of the building. You also need to consider the interconnection requirements of the local utility. Furthermore, understanding the requirements for energy efficiency is also essential for electrical installations. Energy efficiency is the practice of using less energy to perform the same task. Energy efficiency can save money on energy bills and reduce the environmental impact of energy consumption. The National Electrical Code has several requirements that promote energy efficiency. These requirements include the use of energy-efficient lighting, the use of occupancy sensors, and the installation of energy-efficient appliances. When planning an electrical installation, it is essential to consider energy efficiency. You can save money and reduce your environmental impact by using energy-efficient products and practices. Always consult the latest edition of the National Electrical Code and other applicable standards when planning electrical work. Moreover, always hire a qualified electrician to perform electrical work. Electrical work can be dangerous, and it is essential to have it done by someone who is properly trained and experienced. By following these safety precautions, you can help to ensure that your electrical system is safe and reliable. And remember that codes and standards are constantly evolving, so continuous learning and staying updated is vital for anyone working in the electrical field. In addition to the National Electrical Code, other standards and regulations may apply to electrical installations. These include state and local building codes, as well as standards from organizations such as the American National Standards Institute and Underwriters Laboratories. It is important to be aware of all applicable requirements and to comply with them fully.